have a sign, positive or negative. If we don't get significance, we don't care. If we don't get significance, that means there's no difference. If we do get significance, then we want to be able to state that, but the test statistic will tell us which one is smaller. So if we get significance, which we'll go back and look at, then we'll decide. Is that fair? Cool. So let's do the difference. I'm just going to do L1 minus L2 if it's okay with you guys. I don't think it matters. I mean, it doesn't matter mathematically. So there's my differences. There's my differences. I just L1 minus L2. If you do L2 minus L1, you're going to get the exact same results with the opposite test statistic. So mathematically it works out. I'm going to do a real quick graph like I did before. Real quick. Turn it on, maybe. There's our data. I got no problem with it. Slightly more negative than positive. Slightly more negative than positive. Can't tell if it's significant yet. Doesn't look significant to me. Slightly more negative than positive means that we have slightly more. What did we put in L2? Our fingers went in L2, didn't they? That means the finger times were a little bit slower than the thumb times, according to this graph, right? Because if they're slower, that means they're longer before stopping, which means we have smaller minus bigger. But this doesn't look significant to me. I'm curious to see if it is significant. I don't think it's going to be. Fair enough? Let the test figure it out. Yeah? Stat tests, t-test for sure. We still have data. We're still testing against 0. We want to test against 0, of course. Data is still in L3 with a frequency of 1, still raw. The only difference is we got to change the. Oh, no, we don't, because I already changed it from last time. Does not equals. That's the one we want to use. Let's see if there's a difference. Instagram still up. Apologies.
Wow.
There's a little box plot shoved in there too. It's kind of cute, huh?
That's not what mine looks like.
That's not what yours looks like.
No, mine. Mine does not look like that the slightest little bit. No.
That's interesting.
Yeah.
Let me take a look at if you don't mind, after the class, we'll take a peek, Kate, and see who's getting negative 1.67. So a negative 1.67, that's quite a few standard deviations out, yeah? And it's negative, which means on average our data is negative, which means on average the thumb was faster than the finger. Make sure you understand why that is. The thumb is faster than the finger because the finger's times were bigger. Smaller numbers minus bigger numbers equal negative numbers. But what does this tell us about how much bigger? It's not statistically significantly any faster, or conversely, there's no difference in the time statistically significantly measurably.
Would it have to be 10 or 2.5?
It's still the same thing. Check it versus 5%. It's just where the 5% is. It's still versus 5% though. Still versus 5%. So in other words, it's completing number 9 there. It does not appear there is any difference, significant difference. Keep going, keep going.
Between thumb and finger.
Between thumb and finger times. Boom. Could we be wrong?
Yes.
How?
Type 2.
Definitely. Type 2. And who said type 2 was their biggest concern? Type 2 was the biggest concern. So then again, not after the test is over, but before the test is up, you might accept smaller confidence, yes? You might accept smaller confidence to avoid a type 2. And because the reason would be that might be significant at smaller confidence. It's not significant at 95%, it is significant at 85%. And that would minimize your chance of being wrong with a false negative.
Now and look for...
Any goofiest?
No, I mean, now that we haven't increased it. But
Right.
if we wanted to see it, we could go back.
Yes. So Lauren's got a point. Lauren's got a point. Suppose this was significant right here. Suppose that was, the p-value was, say, 1.2% or something very small. Then, you actually wouldn't even have to go back, Lauren. Just look at this guy right here. He'll tell you on his sign.
Oh, right.
Negative versus positive, right? If he's negative, that means the thumbs were faster than the fingers. If he's positive, that means the fingers were faster than the thumbs. Does that make sense? Yeah, so I mean, you could obviously go back and run the test again. What's interesting about your guys' data, is if you were to run a one-tailed test, the p-value would be almost exactly 5%, assuming you picked the right sign. If your theory was the thumbs are faster, then your p-value would be like 5.5%. But if your theory was that the fingers are faster than the thumb, your p-value would be 95%, which means you'd throw it completely out. I'm curious. I'm going to go old school a little bit here and run a t interval to see how you guys did with that world record time. 22.96 seconds, right? Yep, everything's golden. Oh, crap. Did the wrong thing. I gotta test your thumbs and your fingers. Let me test your thumbs first. Let's see how your thumbs did. Oh, you guys actually underestimated the world record by 1/10 of a second-ish.
Harder to reach.
Making it harder to reach, yes, yes. Underestimated on the finger. Curious. Let's check your... Nope, L2, thank you. Thinking ahead in the head now. How'd you do on the finger?
Probably bad.
Finger still underestimated. Interesting. So you underestimated on both. That doesn't affect precision, though. If you underestimated on both, all we were checking was it was a difference in times. We weren't checking for accuracy. We were checking for precision. So maybe what we need to think exactly. Did you catch, even when I erroneously ran the t interval on L3, did you see how this actually echoes what your hypothesis test did? Do you see how that actually echoes the fact that there is no difference between the thumb and the finger? Hold that question. Do you see how this echoes the large p-value? What does it go from?
-1, 1.
To positive, right? It goes from -0.11 to positive 0.01. What number's in there? Zero's in there, right? If zero's in there, this interval doesn't tell you whether you're below or above zero. If you're negative, over here your thumbs are faster than your fingers. Over here, your fingers are faster than your thumbs. And at zero, they're both the same speed. So you can't decide based on that interval, which agrees perfectly with your hypothesis test you just ran, which a two-tailed test will always do, because the confidence interval is two-tailed. Fair enough? Answer that question, Diego.
Well, this will show us who won that race, but it won't help with keeping records of who's.
Oh, no, absolutely. But we were using who won that race as a reference point for our data collection.
Right.
Yeah, you'd actually have to go back and get better data. I mean, I don't have access to the data, obviously, because I wasn't at the meets to test Doug's parents' claims. But at least this, and I've run this test every day since 5 years ago when Doug told me this story. We have never once gotten statistical. This is the closest I think we've gotten, is about 11% p-value. It's usually somewhere close to 50 or 60% of a p-value, which means that there's absolutely no difference at all between it. You guys have come the closest as far as showing a difference, but it's still not there. And every year I go back and tell Doug every 3 months. Doug, don't worry about it. He's like, we're about what? Like, remember, he's like, oh, God, yes.
Leave me alone, John.
Just leave me alone, damn it. Just let you know. What's the data for you? Okay? Next time we'll get together and we're going to answer Lauren's question about 2 samples. When we need 2 samples. When we can't collapse them down. You guys want to turn in the TV ads? Yeah? Yeah. Let's take a little pile up here. I'll try to get them graded and back to you guys on Wednesday. That way we won't wait so much.
Megan.
Excellent. Yeah, stopwatches up here would be great.